Hello, everyone, and welcome to the webinar Getting Started on Alps Platforms. So this is a webinar for the CSCS user community. My name is Luca Marcella, and I will be presenting the slides that we have prepared for the webinar on Alps Platform together with my colleagues, Fosi and Matthias. We are service managers at CSCS. We will talk mainly about the main platforms that we have and the main systems on Alps. So this is the outline of the webinar. We will go through the introduction of platforms. We have then a section of policies and the service catalog, the documentation and troubleshooting, and finally the community Slack space and the status page. So we will go through the slides, and then we will leave at the end of the webinar some time for questions. So you can have questions already written in the chat, but during the webinar, we will not reply, let's say, directly. You might get reply in the chat by other colleagues. At the end of the webinar, you can ask to, with raising your hand if you want to talk. We can give you the possibility to pose your question directly, or you can also write in the chat. So let's go then to the introduction of platforms. So here we begin with some glossary. So by platform, we mean a subset of Alps, our infrastructure, on top of the infrastructure then, that enables the deployment of one or multiple vClusters. A site here that you see in the plot, in the diagram, is a physical place with the facilities that we operate. For instance, we have facilities in Lugano, we have facilities hosted by EPFL in Lausanne, by PSI in Villingen, and by ECMWF in Bologna in Italy. A tenant is an organization that is holding a platform, like CSCS mainly, but we have also Meteo Swiss, we have PSI. A vCluster here is a versatile cluster, so it's an HPC and cloud technology system that provides software-defined cluster on a supercomputing ecosystem. And then we have these services that are versatile cluster microservices that are small, independent, loosely coupled services hosted on a vCluster. Now, we start with the HPC platform. So we call the HPC platform the ones that target the general purpose HPC computing on the Alps infrastructure. The resources that are available on the HPC platform are GPU nodes on Daint on Alps. So we usually shorten that with the word in Daint.alps. That is also convenient because when you access it, you SSH Daint.alps from the front end. We have here a quad socket Grace Hopper super cheap nodes. We have also in the HPC platform the multi-core nodes of Eiger, the dual socket AMD CPU only nodes. The audience of the HPC platform includes the user lab that access the system with peer-reviewed allocation programs, and then partners, for instance, EMPA, ETH Zurich, Marvel, UZI, UZH, and so on. We have also the CSCS2Go program that is targeting primarily Swiss researchers from academia and small and medium enterprises. The HPC platform manages the user access and the allocation through the account and resources management tool. This is the tool that if you have been a user of CSCS in the past, you have been always accessing with the account.cscs.ch site. And there, as a user, you can access your profile. You can have a look at the list of your projects, the active and also the closed ones. You can monitor your project's compute budget with the quarterly allocations, the usage. You can also check the usage of the storage resources, for instance, the home and the scratch, apart from the project's usage as well. Principal investigators, shortly PIs, can use the tool to invite users to the projects and to manage the membership of the users and to control their access to their projects. They can allow or deny users to access systems that are enabled in their projects and also projects data. They can finally define deputies and delegate project's administration, although they are the ultimate responsible for the management of the project. You can find more information at the link provided below. You will have the slides at the end of the webinar, so don't worry, you will get the links. submission and monitoring of batch jobs. So all CSCS systems use the SLURM workload manager for the user jobs management. The most frequently used SLURM commands are the sbatch, the sq, and the scancel commands. So sbatch is the main command to submit a SLURM batch job. In the example, sbatch script.sh will submit a script, a batch script. The sq command should be used with your username with the option -u$user. Then it will check the status of your running jobs, your running pending or other type of jobs, other job statuses. Scancel finally takes a job ID, and then you can remove your job ID from the queue with the command. Other useful commands are the sinfo command, for instance, that provides information on the nodes and partitions available on the system. For instance, here I provide the example with sinfo -sp normal. So this command will provide a summary of the partition normal, showing the time limit of the jobs on the partition and the nodes statuses in short, that is available, idle, other statuses, so not available, and the total number. As you can see, the example here in the line below, it shows that the moment on the Daint vCluster, we have a normal queue that accepts jobs up to 24 hours time limit, and we have a total of 824 nodes, out of which 751 are allocated, 13 available, 16 not available. Please note that some nodes might be reserved. Typically, we have maintenance activities, and you can check these with the command control show reservation. You have more information on the vClusters of the HPC platform, Daint and Eiger, in the CSCS knowledge base. Now we switch to the machine learning platform, and I give my colleague Fozzy the chance to talk. So
the machine learning platform targets AI and ML computing on Alps. It has GPU nodes on Clariden, quad socket Grace Hopper node, like on Daint, and additional vCluster with NVIDIA A100. AMD is not yet available, but it's planned long term. The audience is primarily the Swiss AI initiative that has a goal to build capacity for advanced large-scale AI system for the benefit of society. Over 70 professors from Swiss University and Research Center, and it's co-led by ETH Zurich and EPFL. The documentation and the basic are the same as for Daint. The documentation is on doc CSCS-CH. You have getting started for that. The main cluster currently has 1,300 Grace Hopper node. And there is a smaller Princeton cluster with AMD ROM and A100, which is developed for development and inference and has public IPs. So if you need to do a lot of I/O, it's a good option. You can go. Here is the overview of a single node of the main cluster. These are 4 NVIDIA Grace Hopper with a quick interconnect between both the Hopper part and the Grace, and 4 slingshots cards to connect to all the rest, internet storage, and so on. Container and UENV are both available. Container is the main one of the main ways to execute AI workload. There is a complete documentation on the knowledge base on how to build the image and also use the container engine. For the management, it uses a different portal, a different URL. It's Valdor, called portal CSCS-CH is where you can go to look at basically the same things as on accounts, but for the ML platform. Also there you have projects and resources. And if you go to the next slide, you can see that when you look at the resources, which give how to access a specific cluster, you can see the account that you have to provide to execute jobs in the getting started part of the resource. And go to the next. PIs can invite new members in the team through invitation and add and manage in general from the same interface the group. The basic SLURM and so on, I will not repeat, is the same as for the HPC platform. Something that might be relevant if you have large file is that all our data are provided via Lustre. And in Lustre, you have multiple metadata servers that provide basically things for metadata operation, but also multiple OS for the storage. And Capstore has 160 OS OTS, and IOPStore has 20. And if you have large file, like a Parquet file or so on, you can tweak and inform it to use multiple storage resources, which will improve greatly the performance. And so for Capstore, you can create the file or the directory, and then all the file created in the directory with stripe count 80 and stripe size of 4 megabyte. On IOPStore, 10 and the stripe size of also 4 megabyte gives much improved performance, which can be important with files, large files.
Okay, I hope you can hear me. My name is Matthias Krauser. My name is Matthias Krauser. I'm the service manager for the Climate and Weather platform. Yes, the third big platform we have, mainly consisting of also Grasshopper nodes. And it's called, and it's mainly for the main audiences are climate-based projects around the ICON model. So large project is the Exclaim project of ETH Zurich, but also and also the Center for Climate System Modeling, which is kind of an umbrella for, as you can see, EMPA, 8AH, MetaSwiss, etc. But also UserLab projects, which are using the ICON model, will end up on the Climate and Weather platform. Please go to the next slide, thanks. So Santis is the vCluster. It's the only one, and since most of the setup of the cluster is similar to Daint, so I didn't repeat the commands and the details. There's just a few things I want to highlight. The first one is to connect to Santis, you should use santis.alps.cscs.ch. This is also already active, but currently we also have, for historic reasons, a bit santis.cscs.ch. If you're already using this older DNS, please update your configuration to the new one, which includes the .alps. The shorter one will be deactivated by the end of the quarter. Yeah, it's a SLURM cluster, as I said. It basically provides 3 partitions, normal, debug, and xfer. Here's a table outlining the wall times and also if there are limitations like single node, with the xfer queue being basically the data transfer queue for internal data transfer. The major services currently available are the user environment, the container engine, CI/CD, for example, via GitLab runners, and FirecREST, which is our RESTful API to access the system programmatically. These services will be outlined in more detail further down in the webinar. And currently in development is also the JupyterHub service for this vCluster. And that's it. Thanks.
Great, thanks a lot, Ozzy and Matthias. So we will now switch and talk about policies. So we have general policies that apply to all users that are the code of conduct outlining the responsibilities of the user community. So you should agree to make codes available for support. So the access to source codes in case you are requesting for help. Please be informed that we have a scientific advisory committee and committee members must not be contacted. These are the professors that help the director decide on the allocations. The acknowledgements, you must acknowledge the use of CSCS resources in all publications that are related to your allocations with a reference to the project ID and the name of the code of the project. Then we have the user regulations that define the guidelines for the usage of CSCS resources. So all accounts are personal. Sharing the accounts is forbidden. There is also a data ownership policy that is related to usage of data from other accounts without prior consent from the principal investigator of the project. And this needs to be, it's strictly prohibited, so you need to ask for explicit consent. And finally, last but not least, you have the ETH Zurich acceptable use policy for information and communication technologies. So please be informed that access to the resources at CSCS may be revoked to users that are violating the policies. Then we have data retention policies. So we have data backup for active projects. Data in users, that is your home, and Capstore store, that is the new project storage, will be backed up to the past 90 days. Data in Capstore store folders, so the new project storage, will be removed 90 days, 3 months, after the end of the project without any further notification. So what happens as soon as a project expires? The data backup is disabled immediately. And then there is no data recovery after the final data removal, so after the 90 days from the end of your project. Please mind that there is no backup for data on the Scratch file systems. So we cannot recover data in case of accidental data loss because we don't have any way to do that. And then please be also informed that there is a cleaning policy as will be detailed, let's say, saying shortly. So this is the policies for the Scratch file system. Now we have a larger capacity storage, which we call Capstore in short, featuring 100 petabytes on a Lustre file system that hosts both Scratch and also the project storage facility. So the cleaning policy that I mentioned is that files older than 30 days will be deleted on a daily basis. Some of these policies in some of these folders is not yet in place, but we are activating this policy little by little on Capstore. So you should be aware that you shouldn't use Scratch as a storage. So there is no backup. You shouldn't transfer the data after the batch job completion in order to make sure that relevant data is saved so that you don't risk losing any data. We have soft quotas in order to prevent the performance degradation on the file system. So there is a quote on the total number of files and folders on your Scratch space. These are called inodes. And there is also a soft quote on the total amount of data that you have on your Scratch space. There is a grace time. The grace time means that you have this amount of time to transfer your data before this soft quota becomes a hard quota, in case you go beyond the soft quota. If you are below the soft quota, nothing will change. You can find more information at the link below. We have also fair usage policies, in particular affecting the SLURM workload manager and the login nodes. So the batch scheduler is a shared resource. So continuously polling the scheduler is affecting the performance to all users. So please avoid doing that. In my example at the beginning of the webinar, I suggested to use the SQ command, for instance, with your username only. And please avoid putting in your scripts frequent, like every second, calls to SLURM commands. On top of that, please also do not submit large amounts of jobs in a very short space of time. Here, I mentioned hundreds of jobs in short space, like every minute or every hour, let's say. Up to 1 day should be fine, but then we may be forced to kill jobs and limit new submissions in case the SLURM workload manager is affected in terms of performance by your job submission. Then the fair policy for the login nodes. So these are also shared resources, and therefore compute or memory intensive processes are not permitted on these nodes. Heavy processes will be terminated without any warning. And please be aware that you should submit batch jobs when you want to run application codes. So do not do that on login nodes, but use the compute nodes with a batch script instead. Last but not least, the support policies. So we offer timely response with direct assistance or escalation process to vendors. Now, the support is limited to the scope of your project proposal, and we cannot guarantee the resolution of all issues, although we make the effort to try as far as possible to solve your issue. Now, for supported community codes and user applications, we are committed to help you to run up-to-date supported community codes, although we cannot fix application-specific issues. So the support is targeting the possibility to run the up-to-date version of the code on the architecture that we provide, while there might be bugs in the code. And for this type of issues, you should refer to the developers of the code. We have also a best effort support when deploying or optimizing other user applications that are, for instance, not community codes. And then we make our best effort in order to help you run your code on the systems. We do need to prioritize issues based on the case impact for CSCS, the complexity of the issue that you are reporting, and also the knowledge transfer and the time to solution, because in some cases we have a limited amount of resources in terms of colleagues being able to deal with your issues, and therefore we need to, unfortunately, optimize. Collaborative support is something that you ask you, in the sense that you should consult online documentation and also provide as much detailed information as you can in order to assess your case as soon as effectively as possible. The resource allocation policies are the way we provide computing time on the vClusters to users. So we allocate computing time and we account it in node hours, and we assign resources in 3 months windows. So the quotas, the compute budget quotas are reset on April 1st, July 1st, October 1st, and January 1st. You should use your compute budget as linearly as possible during each window, in the sense that we plan an ideal linear usage, so the budget should be evenly used over the 3 months, and also across the windows over the year. So unused resources, unfortunately, in a given window, they cannot be transferred to the next window. So it is crucial that you consume resources during the allowed 3-month allocation window. Let's go now to the service catalog. So we support a set of services, and multi-factor authentication with SSH connection is one of the most important, as you know, because of security and because it also affects the user experience. So users are required to authenticate using multi-factor authentication. We implemented at CSCS as a two-factor authentication. You receive an email with the details of the procedure. One of these factors is your user login and password. So this is what you know. The other factor is a one-time password, also called OTP. So that's what you get or what you have. The multi-factor authentication applies also to web-based services, not only to the SSH connections. We support any authenticator that follow the TOTP, the open standard. SSH connection to a system is only possible with the keys that are generated through the CSCS SSH service. These keys will be valid for 24 hours. So you need to regenerate the keys after the expiration of the 24 hours since the first time it was generated. So you have much more information on the knowledge base at the link provided below. Programming environment then. We provide several ways for users to build their software and running on the vClusters. Currently, what we support is the UENV, developed and fully supported by CSCS. We also provide a Create Programming Environment, shortly CPE, that is provided as it is, and it is supported only escalating to the vendor, HPE Cray. So please be aware that you are therefore responsible to provide, in case you expose any bug, a full bug report that will be forwarded to HPE Cray, and we cannot guarantee in, let's say, the resolution time of this kind of issues, since typically it might take longer than for internal issues. We have also containers that are often a good choice for machine learning workloads. Please be aware that no modules are loaded by default when you log in on the system. You need to load the module Cray if you want to access the CPE, the Cray Programming Environment. After that, you will find a list of modules provided by the Cray Programming Environment that can be listed with the command module avail. You can find more information on the CPE at the bottom link. A bit more on the UENV, the user environment developed at CSCS. So these are environments providing application software. So they are typically application specific. They can be also domain specific, multiple applications of the same domain, or tool specifics, let's say a certain tool with the dependencies. A UENV is an image that contains only what is required for the applications or the tools to run. We provide some ready-made user environments, but advanced users can also create their own UENV with a set of tools that are provided. These are the image is packaged as a single squash.fs file that can be shared in an Artifactory. It can be stored on any file system. You can also store on your Scratch, and it's completely independent of other images, so they work independently, and they are built on top of the base image of the system and not related directly to the CPE. Just to give you an idea of the tools that are available with the UENV. So the UENV is the main command line tool to access the environments. A useful tool is the UENV image find. It's a command to search for UENV that can be pulled already. More commands are available in the documentation. The tool itself is built on the SLURM plugin and makes sure that the images are spread over the compute nodes that will be allocated in a SLURM allocation. There is the Stackinator tool that generates the images. And then you can find also on the GitLab project a CI/CD pipeline that builds, tests, and deploy images. When you use a UENV, a user environment, typically the mount point user-environment is available with the path of your programs. Let's say you can have compilers, library profilers, like the libraries mentioned here, HDF5 for I/O, FFTW, and so on and so forth. You can also use directly applications. For instance, we support icon builds, and you can find other application environments, like we provide UENV images for CP2K, GROMACS, LAMPS, and other community codes that are typically used by CSCS users. We have also the possibility to have tools in UENV images like debuggers, text editors, or visualization tools. What are the benefits for users? So UENV provide a single image in a SquashFS file. So the performance is completely decoupled from the file system. And they are defined by a simple declarative recipe. So the same environment can be easily rebuilt if needed after an upgrade. And then there is a small set of dependencies because they depend only on SLURM and the lib fabric on the system, so not on the CPE. I mentioned containers as another way for users to access applications and run applications on the system. So this has been mentioned as well by Fossi. So container engine is the primary tool to run Linux containers on our environments. It has been developed following the specific requirements for the HPC systems. And it's also extensible at runtime by means of the OCI hooks. So anything compatible with the Open Container Initiative standards. You can pull, for instance, from Docker, and you can import and convert images with the OCI image format. We have the continuous integration, continuous deployment service available as well. So CI/CD, in short, allows you to build containers and run them at CSCS. You should provide a Docker file with the build instructions and then a name for the container in the registry. So the build process will be taken care by the CI implementation. We have pipelines with webhooks, and the typical pipeline consists of at least a build job and a test job. So a new container with the most recent code will be built in the build step, and the test step will then run the container within an MPI job. FirecREST is another service that we support and is a RESTful API for managing HPC resources. So we integrate it in web-enabled portals and applications, and it allows secure access to services. We have an hands-on introduction with PyFirecREST that is available online that showcases the FirecREST API and the functionality. So basically, it uses HTTP requests to perform several operations. For instance, you can use system commands, for instance, file system commands like ls, mkd, move commands. You can also interact with the SLURM workload manager to submit or query jobs. And you can also use the API for data transfer between CSCS systems and also external transfer. Interactive computing with JupyterLab. So JupyterLab is a web-based user interface for the project Jupyter that allows you to create and share documents with live code and gives you the ability to work with multiple documents. Now, we have recently refactored the JupyterHub implementation to get higher performance. So it should be available soon on the main vCluster, so Daint, Säntis, and Clariden. The notebook servers are launched on compute nodes, and we have a much improved performance because now the Python components are on SquashFS, and we have an integration with UENVs, so you can add your own kernels that are based on the virtual environments that you create on the system. Let's now switch to the storage resources. So these have been briefly mentioned already. I mentioned the capacity storage. So most vClusters on Alps mount the capacity storage capstore as a Scratch file system. It provides 100 petabyte, but they are not all dedicated to the Scratch because they are also shared with the project capstore store storage. Since it is a lustre file system, it has the best I/O performance with large files. So as a rule of thumb, you can take as more or less the best performance is around 1 terabyte per second for I/O bandwidth. We have also a flash file system that is a 3 petabyte lustre file system built on flash memory. This is called IOP store, and this is meant for a high number of input-output operations per second. So with a reduced bandwidth, but it can handle a larger number of inodes. The storage resources are mainly under I mean, in terms of backup storage under /users and /capital store mount points. So these are the storage for data sets, for the codes that you want to compile yourself, for your scripts. The access on these resources, users and capstore store from the user access nodes is with read and write access. Now, we will plan to have read-only access on the compute nodes to avoid performance issues. So please be, let's say, aware that you should not use these storage resources for running jobs. So the Scratch file system is dedicated for that. The storage on the capstore store and users is meant for keeping, let's say, saving results and keeping code and scripts. Folders, as I mentioned, are backed up with a 3-month retention policy that will be closed at the end of the project. And we have some environment variables to allow your quick access to the storage. So $home is the variable that points at your personal folder under /users that you can find also as /users $user. We have also the project and store environment variables that point to user lab folders under capstore store. For the moment, only user lab folders, while for partners, we need some time in order to, let's say, have a better mapping. The data transfer service is enabling to get files from and to CSCS file systems, so the external transfer. This is a service implemented using the Globus Online endpoint that requires your CSCS credentials. We have also on the vCluster a data mover service with a dedicated SLURM queue. We call it internal transfer. So you can submit jobs in the dedicated queue called xfer with no charge. Long-term storage is also another service for long-term retention capabilities, where we provide persistent identifiers, PID, to public access if needed. So you can access the data from a web browser and integrate with third-party application through a RESTful API. And the user lab offers up to 2 terabytes for LTS storage that can be retained up to 10 years. Last but not least, so documentation and troubleshooting. So please be informed that the CSCS user portal has been decommissioned. So I put here a screenshot of the decommissioning news at the end of January, the past month. The documentation has been migrated to the CSCS knowledge base that can be accessed at docs.cscs.ch. It's easy to remember. The announcements, like news, are now sent through the CSCS status page that is accessible at status.cscs.ch. This is a screenshot of how the knowledge base looks like at docs.cscs.ch. So the online documentation can be searched easily. This is implemented through Atlassian Confluence. There are articles displayed in panels. We try to follow the user portal names for your convenience. We have also sections that are new, like how-to articles, troubleshooting articles, and you can easily browse them using the live search. For troubleshooting, so what to do in case of trouble, I briefly mentioned here how to use the service desk. So service desk is accessible at support.cscs.ch. This is a screenshot of what you would look at if you access the page without logging in. So please, I highlight here login first, because this is supposed to help CSCS users, so you should log in order to have access to a set of request types. So once you access the web page, you find immediately useful links on top. So the knowledge base, the status page, and also the tutorials available on the main cscs.ch page. So please submit a support request only if you can't find a solution in the documentation. Once you cannot find it, you should log in, and then please look how to submit a support request. We go through that. Now, we have a set of request types in our service desk. You should select the best matching request type with your issue. So we have, of course, a request type called other request if you can't find any match, but please limit this to just the cases where you can't really map your request, because a better match will also help us react faster to your request. An example of a good support request includes the summary. Let's say when you type in the request, you will be seeing matching articles popping up from the knowledge base. So some of these might be helpful. So please have a look at these. And also in the description, you should provide all the details about your issue. In particular, how we can reproduce the issue. If it is related to a SLURM job ID, include the SLURM job ID and the job script possibly, and copy scripts, source files, whatever is required to your Scratch folder in order to give us the necessary permissions. You can monitor your request in the service desk. For instance, you can filter. There is a filter field, your cases, open, closes, in progress, and so on and so forth, depending on the status of your request. You can also share your requests with other colleagues from the same group. You cannot share requests with colleagues from other groups, of course. It's meant to be, let's say, shared with a certain group of users. You can resolve the request clicking the resolve link on the right of the screen in case you think it was solved. You can also reopen if it was solved and you need to have more interaction. You can also cancel the request if you sent it by mistake. Please be aware that you receive notifications by mail when you submit a request, but don't reply to the emails because the reply is not forwarded. You should use the service desk online in order to add comments. Then last, to close, I would mention the new tools that we have in order to get in touch with users. The community Slack space that we call CSCS user Slack, accessible at the link provided, or you have also the QR code. This is a new space to interact with fellow CSCS users in a community-driven approach in order to get rapid responses to quick questions and share your experiences. You should encourage your team members to join, but also please be kind and considerate to other members because misbehavior could result in a ban. And you can browse many channels available. I mentioned here some main channel like the Daint channel for the vCluster Daint.alps, so the general channel, that's the default in Slack in Slack spaces. You have also the introductions channel if you want to introduce yourself to your colleagues, but there are more available. And please be aware that this is not meant for support requests. For that, you should turn to the service desk. And the status page that I mentioned for announcements. So we have the status page that reports the status of some services. This is the main services called central services at CSCS, like front-end availability and other services like FirecREST and the CI/CD. It can also show announcements and schedule events. And you can subscribe, as you see the link on the top right, in order to get email notifications about new announcements and events. So I conclude here with the useful links. I would like to thank all attendees and to thank my colleagues for joining and contributing to the slides and to the Q&A session, and also for supporting us in with the webinar infrastructure. Thank you all, and hope to see you on the Slack user space.